Hello, good afternoon everyone. My name is Aditya Shrestha and I'm a student of Masters in Leeds Beckett University at the British College. My student ID is c7575198 and I'm going to present about the semantic analysis, analyzing deep learning models on movie review dataset, which is my dissertation topic. Now moving forward, with the rapid growth of online platforms, people express their opinions and emotions more than ever before through product reviews, blogs, social media posts, and feedback systems. This explosion of text data makes the sentiment analysis as a more important area of research. My work investigates and compares deep, three popular deep learning models that are Bayesian, BERT, and Hybrid, which is the combination of both BERT and Bayesian model for sentiment classification on IMDb dataset. The focus was not just on the computational accuracy, but it is also but it also focuses on computational efficiency, interpretability, and deployment feasibility. It evaluates the criteria of accuracy, precision, recall, F1 score, and confusion metrics, as well as computational efficiency such as training time, memory, and carbon emission. The results show that while BERT beats Bayesian in all metrics but with larger computational cost, whereas hybrid, being a middle ground, utilizes the contextual power of BERT with sequential power of Bayesian. The trade-off highlights between the accuracy and resource requirement provide a lot of practical advice when it comes to choosing a model and prompt for hybrid and aspect-based sentiment analysis approaches to be investigated further. Now, for the overview of my research, the study asks a simple but important question, that is, which model is best practical and effective for sentiment analysis in real-world setting. Talking about the Bayesian, it is a lightweight, efficient, and interpretable but uses static embeddings, whereas BERT is the state of art that uses contextual embeddings in terms of transformer but is resource extensive. Talking about hybrid, they combine the contextual embedding from BERT with sequential modeling from Bayesian. By directly comparing them under the experimental condition, this research aims to provide fair, reproducible, and practical highlights. Now, let's move on to the research question. Sorry. Uh, the research question for my research is, how do Bayesian, BERT, and hybrid model perform under identical conditions? What are the trade-offs in memory usage, training time, and inference latency? Which model is best suited for real-time or resource-constrained setting? How interpretable are the predictions? And what are the ethical issues arriving in deploying RAS NLP models? Let's come to the aims and objective. My aim of the research was to perform a scientific comparative study of these three models on binary sentiment classification using IMDb dataset. The objective include implementing BERT, Bayesian, and hybrid system for sentiment classification on IMDb dataset. Also, fine-tuning models, example BERT with learning rate optimization and Bayesian with globe embeddings. The third is evaluating using metrics, accuracy, precision, recall, F1 score, confusion matrices, and resource uses, which include memory and training time. The fourth includes comparing standalone versus hybrid model to leverage BERT contextual strength and Bayesian sequential modeling, and to analyze trade-off, that is BERT's 92% accuracy versus Bayesian 86% but higher resource cost. Also to recommend future directions like hybrid enhancement and aspect-based analysis, sentiment analysis. The background for the research is the sentiment analysis extracts the opinions or emotions from text, which is widely applied in social media reviews and customer feedback. Traditionally, the lexicon analysis was used. Then came the ML methods such as naive Bayes, support vector machines that struggled with the context, sarcasm, and long-term dependencies. However, with the new inventions and exploration, deep learning came, known as Bayesian, which improved the sequential modeling and contextual flow but lacked dynamic embeddings. Then came the transformer BERT, which revolutionized the NLP with contextual embeddings and self-attention, achieving state-of-art performance. The rationale of the study is to provide a controlled, reproducible comparison of Bayesian, BERT, and a hybrid model, an IMDb dataset, not just evaluating accuracy but also efficiency, interpretability, deployment feasibility, and ethical concerns. Now let's come to literature review. Uh, Briefly explaining, we can say that from the early approaches that uses the lexical method, where dictionaries of sentiment words were used, they lack the power to evaluate the sarcasm, negation, and domain-specific term. Then came the machine learning approaches like naive-bayes, SVM, which improved the performance. However, required manual feature engineering and failed to capture the long-range dependencies. Then came the evolution of deep learning architecture, particularly these LSTM and BiLSTM, uh, CNN, that were a breakthrough in handling the sequential data and learning the sequential data and solving and vanishing the gradient problem. BiLSTM improved the context by reading in both directions. Then came the evolution of transformers that revolutionized NLP. BERT pre-trained on massive corpora achieved the state of art. However, BERT is resource hungry and less interpretable. Finally, the hybrid models were introduced that have emerged recently, combining the BERT embeddings with LSTM or CNN. Studies suggest they outperform standalone models, but few works have compared them under experimental settings. So, my research outlines or contributes by filling this gap with a controlled evaluation of BiSTM, BERT, and hybrid model. Let's move to methodology. These are the architectures. Sorry. These are the architectures that I have used to implement these research. The first one is the BERT architecture, where the text or data are inputted, then they are pre-processed with the help of tokenizer, CLS and SCP attention max. Then the BERT is encoded for first 12 layers. The bottom 6 are frozen, top 6 are fine-tuned. Then the classification is done, and finally the softmax is used to get the sentiment. The second is the BiLSTM architecture, where the text is inputted, they are tokenized and sequenced. Then the embedding layer, that is globe embedding, is used. Then two layers are used with 64 and 32 hidden units with dropout rate of 0.3, and the sigmoid activation function to give the predicted sentiment. Finally, comes the hybrid architecture, which takes the review of the data that is input, then is transferred to the BERT embedding, sequentially transferred to the BiSTM layer, and then the dropout rate is used and connected to the fully connected layer to give the output. So, in this research, I have used IMDb dataset that contains the 50,000 balance samples. Balance sample indicates that it has 25,000 positive reviews and next 25,000 negative reviews. Uh, then the BiSTM contains two layers with 64 and 32 units, along with glove embeddings, and dropout and a sigmoid classifier, whereas BERT use the BERT based on-case fine tuning with partial freezing, where top 6 layers are unfrozen using the Hugging Face trainer and optimized with RMW, whereas in hybrid model, BERT embeddings are passed into BiSTM layer, followed by a dropout and a dense classifier. The environment that I have implemented the project is in Google Colab with T4 GPU, and the evaluation that I have done are accuracy, precision, recall, F1 score, confusion matrix, training time, carbon emission, and memory usage. Now let's discuss about the results and discussion. result and discussion here. While moving into the bird, we have seen the maximum accuracy of 92%, but it is very it is resource intensive, that is lot of GPU is used and long training time is seen, whereas in Biostem there is the lower accuracy 86%, but it is lightweight and faster and is best for real time slash low resource system, means mobile devices. And in hybrid, the competitive accuracy is found to be 95 percent, sometimes surpassing the bird in balance matrices. In Biostem there was the low memory consumption, that is up to 1.6 GB, and the fast training was seen, that is 63 seconds per epoch. While comparing it to the bird, the it has the highest memory usage, that is almost double that of Biostem, found to be 3.2 GB, and have the slowest training time, that is 750 seconds per epoch. Now talking about the hybrid, the accuracy is best among the all three, that is 95%, and training time is in between the Biostem and bird, that is almost 460 or 450 seconds per epoch, and the memory used is 2.3 GB, which is better at handling the sarcasm, long sentences, and sentiment shift. Here are the list of classification report achieving the accuracy, precision, recall, and F1 score, and the below table shows the use of the hyperparameters across different model, that is the batch size used for Biostem is 64, BERT has 16, and hybrid has 32. All of them have the same epoch numbers. It is also seen that if the epoch is run more or raised to 3 or 4, the overfitting is seen. The graph first converges and then diverges, so a case of overfitting is seen. The maximum length for BERT and Biostem is taken as 256, whereas for hybrid is taken as 128. These are the learning rate and optimizers used. So in discussion, I would say that the BERT has the best accuracy, that is suitable for uh, s- suitable when the resources are abundant, and Biostem is the efficient, which if the we have the low resource set environment and real-time application, and the hybrid has a balanced compromise leveraging both contextual and sequential strengths. The conclusion would be again the same, that while comparing the three models, we guess the best as the hybrid for accuracy, but if the time is seen, then Biostem would be recommended. So these models can be used for sentiment detection. The study suggests that Biostem model runs fast with minimal computing resource, while BERT enables the better contextual understanding. However, the hybrid model ensures it has the best accuracy of 95% and F1 score of 0.97. Therefore, combining the two paradigms to procure a balance between the prediction power and efficiency with robustness against linguistic issues arising due to sarcasm and sentiment strength shift. In a nutshell, this finding shows that the hybrid model is the most useful way for actual sentiment analysis, giving a good compromise among accuracy, scalability, and computational resource cost. For the ethical considerations, I have seen in the previous literature review that none of the system uses the same environment, that is the same training data set or the same number of epochs and so on. So in this research I have considered about the fairness, giving the same uh, training environment, and also that no personal data were collected as I have used the secondary data. Then there comes the list of references that I have referred for conducting this research. And thank you so very much. Thank you.